Hello, this is Wellington with PX5, and today I'll show you how to work with ticktimers using PX5 RTOS. So in this video, we'll run through the ticktimer APIs, then I'll do a 2-minute demo, and then I'll share some resources. The ticktimer APIs we'll see in this presentation are not part of the standard POSIX thread APIs. They're actually part of the PX5 RTOS extended APIs. This is the reason why they all have the PX5 prefix. With the use of these ticktimer services, you can retrieve the current number of timer ticks, you can have a thread sleeping for a determined number of timer ticks. You can also have a tick-based application with both one-shot and periodic timers. There are plenty of ticktimer APIs. Make sure to check the PX5 RTOS user guide for the full list. Now let's dive into the APIs. Before we can use a ticktimer, we first need to create it. To do that, we call the ticktimer create API, passing first the handle of the ticktimer, then any optional attributes you may want to use, then the number of initial ticks before expiration, and this value must be a non-zero, the application routine to call when this ticktimer expires, and then the number of ticks for periodic expiration. So if this value is 0, this will be a one-shot ticktimer. Then we can check the return for errors. Once we create a ticktimer, we can start using that by calling the ticktimer start. For that, all we need to pass is the handle of the ticktimer to start. Then we check the return for any errors. The sample we'll see now is based on a single thread and a function that is triggered by an ISR. So the main thread will create and start the ticktimer, and once this ticktimer expires, the function is called from the ISR processing. Okay, let's see these APIs in action. As always, main start running by creating variables, thread handles, and the memory area. In this case, we also have a ticktimer function, which is called by an ISR, an interrupt service routine. Next, in line 5, we start PX5 RTOS by passing a random number for pointer data verification. We see what that is in a different video. The memory area and the size of that memory area. Now this will be converting main into a thread running at the standard priority of 16. Next, we'll create a ticktimer passing the handle of the ticktimer, any optional attributes, in this case null. Then the application routine to be called when this ticktimer expires. Any arguments needed by that function, so in this case null. And then the number of initial ticks before expiration, 1. And the number of ticks for periodic expiration, 1 as well. Notice now we have this ticktimer created. It will expire after 1 timer tick and then periodically 1 timer tick after that. Next, we'll start this ticktimer. Now it is running, and main will increase its counter until this ticktimer expires. So now main incremented its variable to 1, now incremented to 2, now this is at 3, and then the ticktimer expires. You can see the expiration value here is 0, so the ticktimer entry function is called from the ISR processing. This ISR will preempt main, which is now in ready state, and allow the ticktimer entry function to run. The ticktimer entry function then will increment its counter variable. The ticktimer expiration value has been reloaded since this is a periodic timer. And main will resume until this timer expires again. That was the short demo we had for today. As always, if you want to get started, make sure to visit our website at px5rtos.com. You can email us with questions, request for information, or a quote at info@px5rtos.com. Thank you for your interest.